Good morning, everyone. So how many building officials we got? Okay, architects, builders, other, Atlas Insulation, Arnold Lumber, I know you. Hi, how are you doing? Good. And who else raised their hand? Where do you guys?
Energy Raider.
Energy Raider. Okay, great. Excellent. Who do you work for?
I'm currently on waivers. I'm doing my BPI work, and I've been so busy. I'm an appraiser as well. I've been doing appraisal work and doing home energy audits.
Yeah.
Energy New England. I want to start doing virtually.
Well, get ready because this 2024 code is coming, and we're going to need you.
Yeah, I need a provider too.
Yeah. Yeah. Well, let's chat later. And one more? Arnold Lumber. Okay. Nice to meet you all. My name is John Erickson. I'm an account manager with ClearResult, as Karen mentioned here with the Rhode Island team. I'm also a certified passive house consultant. I teach the builder trainer course for FIAS. I'm a verifier, HERS rater, a bunch of different things. So today we're going to talk about the 2024 IECC code update, but in a very specific way. I'm not going to go through the whole code today because it is extensive. I'm going to go through two of the most important components of the new code that's coming. And then I'm going to hand it over to Steve Demetric here, who's going to talk about, particularly about airtightness today, right? Yeah, so let's, before we do that, let's talk about the new construction program that Karen mentioned. Has anybody here been involved in the new construction program? Nobody. Okay, so if you're an architect or a builder or you're doing a major renovation on your own house, you can go through our program here. And how it works is we have a baseline home that we will compare your project to in terms of energy efficiency. We build an energy model for your house, compare it to the baseline. And if you hit 25% better than that baseline, you get $500. If you hit 40% better or more, you get $4,000, right? Also, there's some other incentives for different certifications, and there's also equipment rebates that we put through the program as well for heat pumps, heat pump hot water heaters, these kind of things. And in addition to this, our program also includes free consultation. Yeah?
Where do you sign up?
You can just email me, any one of us. So I'll give you the email at the end here.
I will send you a post email. I'll put the link to that.
Yep.
So that way you know exactly where to go to find that. But I would also like to just mention that the equipment rebates that he was talking about is on top of that.
Yeah.
So you get...
You can apply for equipment rebates yourself, but we just throw it into the program to make it easier. So if you're going through the program, it's just we just do it for you.
Okay.
Right. And in addition, we do free consultation with this program as well. So we'll take a look at your plans and help you to make informed decisions on the energy efficiency of the house. Okay, so let's start off. So learning objectives today. First, I'm going to talk about airtightness and how it pertains to the new code. Talk about airtightness historically in Rhode Island, what's the new requirement, and then talk about it holistically. Why is it important to build your house tight? And then I'm going to talk about this idea of prescriptive versus performance compliance, okay? This is probably the biggest piece of the new code that we're going to need to address, is this down here. So these two things, and then I'll hand it over to Steve. So starting with airtightness. So in order to understand where we are in Rhode Island in terms of the airtightness requirement, let's look at sort of historically where we've been and where we're going. So right now, Rhode Island is using the 2018 IECC model code, right? That's the version that we're using now with Rhode Island amendments, right? So it's the model code, and then these amendments are layered on top of it. So 2018 model code says that right now we should be at 3 air changes per hour at 50 pascals, right? 3 ACH 50. Does everybody here know what ACH 50 means?
No.
Okay, so ACH 50 is the metric that we use to determine how tight a house is. We depressurize or pressurize the house to 50 pascals of pressure, And then we have a pressure gauge, a manometer, that reads how much air is moving through that fan at that pressure. And then that's how many air changes the full volume of air in that house per hour moves out at 50 pascals. So it's the metric. 3 is not that tight, but also tighter than what we have now. So Rhode Island, so here's the 2018 model code. Here's the snip from that. And then Rhode Island put this amendment in that has I don't remember, when did this go in, Gordon? Do you remember?
What?
When did this amendment here?
In theory, we haven't adopted it.
Yeah.
Not formally put in, but the energy code is going to be 2024.
Right. But the code that we're currently on right now is 18. Yeah, it's R19. So, right. So in 19, this amendment got put on to the 18 code. So it says in 2019 we go to 8, then we go to 7 in 2020, then to 6, and then in 2022 we go to 5. In subsequent years, I think that's supposed to try to be a cap, right, to keep it at 5 ACH 50. Okay. What does that look like? So here we are on a timeline. This is what it looks like on the timeline for Rhode Island, right? And here we are, 2023. We're still at 5 ACH 50. Okay. Let's compare this to our neighboring industry-leading state, Massachusetts, right? And what they look like. So in 2013, they adopted the 2012 IECC, and they went to 3 ACH 50, and they've been at 3 ACH 50 the whole time, right? What does that mean? Well, I'm going to show you in a second. What's the difference between this and this for Rhode Island homeowners, right? But what's happening now is Rhode Island passed a law recently. We will be adopting the 2024 IECC within 3 months of its release with no amendments, and subsequent editions of the IECC will be adopted within 1 year of publication. So we're going from essentially right now, our code is close to what 2009 is, okay, equivalent. We're going from 2009 to this code, 2024. This code is very different than what we're doing now in a lot of ways, all right? So here's the airtightness requirement in the 2024 IECC. By the way, this is still in draft form. This hasn't been published, but they're on the second draft, and I believe that the second draft is for corrections of addenda, typos, and things. I don't think that they can change content at this point, so this should hold. But still at 3 ACH 50 for the 2024, okay? So the IECC, the ICC recognizes that 3 ACH 50 is kind of the sweet spot, right? It's been there since 2012. All right. So why, let's ask this question. How many people here have heard the term "a house needs to breathe"? Okay. How many people here have heard the term that you should build your house airtight? Okay. Which one of those is correct? Both of them are correct? Okay. Yeah?
People need to breathe, not houses.
People need to breathe, not houses. Okay. Why does the ICC and the broader building science community and high performance builders, why do they want us to build our houses airtight? What's the point of it? Energy savings. Okay. Are there any other reasons? To control moisture. Any other reasons? Increase comfort levels. Healthier environment. Okay, let's talk about energy savings for a second. So, I saw this, and about a year and a half ago, I said, there's got to be a way to quantify what the difference between these two things are, right? So, working for the new construction program, I have access to a hundreds of energy models that we've created for homes that go through our program for HERS ratings. And I took 40 houses randomly, not totally randomly. I made sure that they were within a certain square footage. I kept the outliers out of it, right? And I got sort of your average Rhode Island home. I took 40 of them, and I took the energy model and I set it to 8 ACH 50, and then I set it to 3 ACH 50, and I said, what's the difference in terms of lost energy over the course of a year? So I did that at 8 ACH 50, at 7, at 6, and at 5. I extrapolated that onto the past decade of Rhode Island, right? I went to the Census Bureau. I saw that there were about 9,000 permits pulled for single-family homes. Okay, this does not include multifamily. And the amount of lost savings just from the airtightness, this is just airtightness, right, is 147 billion BTUs, right, over 10 years. So
40 homes.
for all of these, I extrapolated for the 9,000 permits pulled for single-family homes.
So that figure applies to all new homes built?
All new construction homes, yeah, more or less. This is not a perfect science, but it's going to be close, right?
Over a period of what, 10 years?
Over from the 2012 IECC up until 2021 is when I did this. So what that is, what is a BTU? Can someone describe that to me? What's that? The British thermal unit. Do you know how much energy is in a BTU? So, yeah. 1 pound of water, 1 degree Fahrenheit. An easy way to know what a BTU is, it is about the equivalent to the energy in a wooden kitchen match. So that's 147 billion wooden kitchen matches worth of energy. So what does that look like? What does that mean? So if we were to extrapolate that into home heating oil, right? How many BTUs are in a gallon of home heating oil? Does anybody know?
140?
Oh, 138,500. Yes, close enough. So if you take that number up there, that's about 20,000 barrels, 55-gallon barrels of home heating oil that we just dumped down the drain, right, for homeowners. So in terms of energy, it is significant, right? But is this the prime reason that we build our houses airtight? Is it about energy? You said to keep moisture out of assemblies, right?
No,
To control it. You talked about healthy indoor air quality. Somebody said comfort, right? Did you say comfort? Somebody said comfort, yeah. So really, in terms of energy, it's important, but let's talk about it, the building science of it real quick, all right? So the idea is keep the outside out and the inside in. That's what we're trying to do in our houses, right? In our buildings. So what are we trying to keep in and what are we trying to keep out?
Depends on the time of year.
So you're talking about heat though, right? Heat energy, right? We're trying to keep heat energy in the heating season, we want to keep it in the house. In the cooling season, we want to keep it out of the house in the summer, right? What else are we controlling for? Moisture. Water, bulk water, but also water vapor, right? Water vapor is much, much smaller than bulk water, right? So these are two different considerations. And then what else are we trying to keep out of the house? Pollutants. Yes. What are some pollutants that we want to keep out of the house? Radon, mold. If you live near a road, carbon monoxide, right? What are some pollutants that we want to get out of our house? Yep. Carbon dioxide. Yep. PM2 particles from cooking, right? How about VOCs potentially from off-gassing? right? There's all kinds of pollutants inside and outside that we want to control. We don't want to let these things move through our assemblies willy-nilly, particularly this. We don't want water vapor moving into our wall assemblies, especially in the wintertime when you have cold assemblies, right? If you have cold sheathing and you have a moist environment in the house and that moisture moves into that wall assembly, it could condense on that cold sheathing. So we want to keep it out, right? Okay, so we do this, we control for these things with 4 control layers. There are 4 critical control layers, right? So there's the water control layer, we have the air control layer, we have the thermal control layer, that's our insulation, but it's also our windows and our doors, right? And the water vapor control layer, that's your vapor retarder, right? So these are the 4 control layers. This is a pretty common way to install them in this order, but it doesn't have to be like this. The water vapor control layer moves around a bit sometimes. And some of these control layers can be the same material. They're not always separate materials, but you want to consider them as separate materials when you're looking at the building science, okay? And then one thing, I'm going to talk about this afternoon, but you can't talk about the air control layer without talking about mechanical ventilation, right? So I'm going to talk about that more this afternoon. These 2 things are peanut butter and jelly, okay? They go together, and they have to go together. Okay, so what rides on air? Heat, water vapor, water and to a certain respect, and pollutants. So all of those things that we're controlling for ride on air. So how important is the air barrier? Exceedingly important, right? It's the umbrella over all of it, right? Okay, so here we go. What's happening? We're standing in an attic, right? Unconditioned attic. We're looking at the back of a roof deck. So what's happening here? What are we looking at? A leak. What's this? What's this? And what's this? It's a leak? Is it a leak?
No, it's going to be water.
Water's condensing. Condensation on the nails.
What's this down here?
That's an air leak from warm air.
So there's probably a bathroom under here, right? So why is there ice here and then bulk water here?
Warm air comes up from the conditioned environment.
Warm air, this hasn't been sealed. The hole around this pipe hasn't been sealed. It's a bathroom. There's hot, wet air in there. Hot air is buoyant, so it moves up. It's loaded with water vapor, right? And it condenses on the back of this nice cold roof deck in the wintertime, right? You can see 3 active holes in this ceiling assembly, right? This, by the way, is the dictionary definition of an ice dam, right? If there were 10 inches of snow on this roof, this would have an ice dam. Because what happens is the snow melts right here, it rolls down and refreezes, more snow melts, it rolls down and refreezes, and eventually starts working its way back up. Okay, so what's going to happen when all of this ice melts in the spring? You're going to get this kind of thing, potentially. Not definitely, but potentially, right? Now, what happens when you have this? What happens when you have a duct system up in this attic, right? What's the average duct leakage in Rhode Island? Does anybody know? It is 22%. 22% is the average duct leakage in Rhode Island. Put a 22% duct system, leaking duct system in this attic, right? It's leaking on the supply side and the return side. So now you have a mold delivery system in your house, right? So here's the question, right? So this is an example of, well, let me ask you, what does it mean when you say a house needs to breathe? What do we mean by that?
It needs a chance to dry out if water gets into it.
What does it mean, though, when we say a house needs to breathe? What does a breathing house look like?
Air moving through
So this, well, that's attic ventilation. That's different than this. This is leaking on the air barrier plane, right? So this is an example of a house breathing into the attic, right? And this is what happens when you let your house breathe. You allow these kind of things to happen. If we are endeavoring to build a house with really good indoor air quality, how are we going to do that when we get these kind of situations? Right? Okay, here's a picture that Steve sent me. This is from one of Steve's houses. This is a Zender energy recovery ventilator, right? Steve uses these in all of his houses. He's probably going to talk about that, I think, but okay, he's not going to talk about it, so I'm talking about it to you, okay? So this will be in the next section. I'll talk about ERVs and HRVs, right, in the afternoon. So this is one of Steve's houses that was built very tight. I think you were like a 0.3 ACH 50 on this, somewhere around there. And he pulled the filter on the Zender, and that's what this is all pollen, right? So the filter of this ERV caught all that pollen before it got into the house. If you had a house breathing, a leaky house, that pollen just comes right in wherever it wants to, right? Last bit about airtightness here. So this table has been in the code since 2009, and it hasn't changed much. It's improved a little bit. This table goes way down if you want to look it up. I'll show, if anyone wants to see it, I'll pull it up at the break. This tells you the air, it's air barrier and insulation criteria. If you follow this table, you should be able to hit a 3 ACH 50, right? It's designed to help you figure out how to hit these numbers, okay? But what I want to point out is the very first requirement in this table is this, right? A continuous air barrier shall be installed in the building. That's really all you need to know about how to build your house airtight, right? There's a continuous air barrier that goes all the way around the house. It's not one material, it's a system of materials that you piece together to create one perfectly continuous air barrier. So, continuous, forming an unbroken whole without interruption. I hear builders tell me they're going to use their Typar or their house wrap as their air barrier. You can do this, but it is very difficult to get a perfect air seal with a mechanically fastened membrane. Because if there's a hole in it, right, the air can move through that hole and then move all behind it. So when you look at something like this, right, so it's not taped down here, it's not continuous. This is now doing nothing if you don't tape that, right? It's working as a water control layer, sure, but not as an air control layer, right? All of these need to be repaired. Who's doing the quality control on that, right? Who's coming back and taping all this stuff? I'll give you an example. This is a house that went through our program. This is a modular home. The homeowner asked the modular company if they would tape the sheathing for airtightness based on my recommendation. They said, no, we don't do that. We use the Tyvek as our air barrier. And they set the house, and they're going to come back and tape this. What is the probability that this is going to become a continuous air barrier? Almost zero, right? Almost zero. So we can take a look at one of Steve's houses here. How about that one? How much easier is that, right? So, yeah.
Isn't there another issue with the Tyvek, aside from the fact that it doesn't last very long? Is every time you put a nail for the siding, you're putting another hole in it, right? So that's going to have thousands of holes.
Potentially, yep. Yep. It is not a very robust way to do your air barrier.
Every time you nail the sheet of plywood, you put it in pieces of skin. So if you don't fill every nail hole in the plywood, it's already leaking.
So Huber, who makes this product, they did a study on that. If you set the nail into a framing member, it doesn't affect airtightness at all. If you miss the framing member and leave the nail in, that will create an air leak, or if you pull the nail out and don't fill it. But if you hit a stud with that, it doesn't affect it.
Piercing the skin doesn't affect it?
Piercing the skin won't affect it, as long as you're hitting a framing member. If you set your nail too deep, you might have to worry about the water control piece of it. But in terms of air barrier, it doesn't do anything. Get that question all the time though, yeah.
I use the paper because it's fine. You can flash over the top of windows, doors, flashing.
Right. You can put paper. You can put the paper over that, but don't use it as an air barrier. That's your air barrier, right? It's two separate functions. There's your water control layer and your air control layer. When you try to use this as both, it's problematic.
What about closed cell spray foam?
We're not going to talk about that right now.
Is that a big water barrier?
It is. Yeah, I don't want to go down the spray foam road right now, so if that's okay, just for a time. But I can talk to you about that at the break, if that's okay. Yeah, I'm not a big fan of spray foam. I can tell you that under any circumstance. So maybe some can foam for sealing stuff up.
Better qualify, because that's what's being used in Massachusetts in order to achieve this.
It is not necessary at all. What's the R value of open cell spray foam? It's 5.5 inches.
5.5 inches, it'd be just about almost 30.
5.5 inches of open cell spray foam.
Excuse me, 21.
21. What is the R value of 5.5 inches of fiberglass bat? R21. If you tape your sheathing like this and put in fiberglass bats, what's the difference between this and open cell spray foam?
Okay, but now how are you going to do it when you've got your assembly is, let's say, your block is whatnot. In Massachusetts, you can't use fiberglass. You have to go back individually and put a piece of
So in the rim is a potentially decent application, but if your air barrier comes down over the rim, then it doesn't matter. You're not using it as your air barrier. This is why I didn't want to talk about spray foam.
In the field, it's hard to do what sometimes you guys want to recommend.
We're going to let Steve address that, okay? Yeah. Yeah, we can talk to you about that, yeah.
Yeah, we're doing passive house level work with zero spray.
And I don't doubt that. I'm just saying that the majority of construction, especially if it's spec and whatnot, you can't justify the cost factor. Even your program, we've tried to do it with some builders. When they see how much it costs to do it, they say it's not worth it.
To do what?
To get some of the benefits.
To tape your sheathing?
No. The bigger picture. Some of the guys, it's all about the dollar.
Yeah.
So even though your program might say, reduce your air flow, and we're going to give you X amount, they say, well, how much is it going to cost me to get to here?
I
And
do
then they say they don't want to do it.
I do it affordably. We do market rate construction.
Okay,
Steve's gonna talk about this, yeah.
It's about knowledge.
okay.
Yeah.
You learn how to do it, it's actually cheaper. I'm glad you haven't had to manage to build net zero homes, and they're doing it with zero
Yeah.
knowledge and volunteers.
Really?
Oh, yeah.
Okay.
All right, let's talk about this piece, prescriptive versus performance compliance. So, first of all, what is prescriptive compliance? Somebody want to define that for me?
It specifies the exact procedure.
Yeah, so this is like a recipe. Prescriptive compliance is a recipe, right? Rhode Island's recipe is like this right now, currently, right? This is the recipe for how to make a hard-boiled egg, okay? This is very easy to accomplish this right here. So here's our current model code, is 2018 IECC. There are 3 ways to comply with the energy code, okay? There's the prescriptive, there is something called total building performance, and then there's the ERI rating index option. These 2 are what we call performance compliance, okay? What that is, rather than looking at specific components of the assembly, you take the whole house, you build an energy model, and then you can swap things out, but as long as it hits a certain number, then you comply with the energy code. So you wouldn't necessarily have to follow this recipe, you could create your own recipe. As long as the whole house meets the needs of the energy code, then it complies. That's what performance compliance is. Rhode Island's essentially amended this out, performance compliance. So this is our Rhode Island amendment for this code. We said, okay, so you can do the 2018 IECC, you can follow that. You can follow the 2018 IRC, both of those are prescriptive, right? By the way, those two things are the same thing. Those are the same thing, right? Or you could do a res check, which doesn't even make sense because a res check is just a piece of those two things which are the same thing. These three things are the same, and they're all prescriptive compliance, okay? So here is the 2024 draft IECC prescriptive table, right? So if you're a builder and you're going to do prescriptive code, this is what you need to do. And you can see some differences here that are pretty big. So here's the U values, here's the R values, which most of us are familiar with. Well, windows are going down to 0.28, right? Ceilings going to R49, all right? All right, some of these aren't too bad. Here's the one that is the kicker for builders that want to use prescriptive compliance, is that. How many of you are doing R30 in your walls, or R20 with 5 continuous on the outside, or R13 with 10 continuous, or R20, which is basically a SIP? That's the kicker in this code for prescriptive, right? Most builders, they do 2x6 with fiberglass bats or spray foam or something else, cellulose, right? So now you're talking about putting exterior insulation, you're talking about window bucks, extension jambs, overhangs are changing, rain screens, right? This is going to add a lot to cost for most builders, right? So forget about it because we have performance compliance, okay? You can forget about these tables, essentially. All right, so 2024 draft has, again, they changed it to simulated building performance and to the ERI index option. I'll explain how these work, right? This is how energy compliance works in Massachusetts, in New York, in Connecticut, and some other states, right? This is how you do it. So you as the builder, you come to one of us, HERS raters, and you give us your plans. We build an energy model, right? We go through it together. We say, okay, these windows aren't good enough. Add a couple inches of cellulose in your attic. Okay, you can bring your airtightness down. You go through the different options, right? And then we spit out our compliance. The energy model will spit out the compliance, yes or no. So for instance here, this was a house I was working on, and I was just, this was an example I was working on. I was running this through the 2021 code to see how this house would perform. So it didn't meet prescriptive, but it met this performance one here, check. So yeah, you're good. Here's your permit. You met it. You didn't meet the prescriptive, but that's fine because you met it here. Okay? Then we come out. What's that?
How'd you meet it there?
I've got an example.
Yeah, but if we're just building, we're not signed up for the program.
Yeah.
We'd have to put the R30 in the wall.
You would have to do prescriptive unless you can find an energy rater to come and do it. Yep.
Okay.
So, and I'll show you what that looks like in a second. I got a couple slides for you. So then you got your permit, you start building the house. Your rater is going to do all of the inspections. Building officials do not have to do any of these inspections if you're doing it this way. Okay, the rater comes out, is going to test, is going to look at air sealing details, right? We're going to look at the windows. We're going to do all this verification, blower doors, collect all the equipment numbers, right? So this sort of third-party verification is typically, it's a lot more robust than your standard energy inspection from the town. So third-party verification is a really great thing, I can tell you. As a former builder, I never say, well, why should I certify my house? Why should I certify as Energy Star or something? You know, who cares? I'll just build it as a passive house. Well, the problem with that is that you don't get the third-party verification of somebody coming in and really digging in and making sure everything's okay. And it's not about you as a builder messing things up. Mistakes happen, things happen. And it's good to have somebody there spotting all this stuff, right? So this is some of Steve's work here, actually. But we'll come out, we're looking at insulation, we're measuring insulation. Sometimes we'll do density samples on dense pack to make sure that the machine's blowing in at the right density, or else it'll leave a gap, right? It'll settle. Looking at air tightness, windows, checking wattage on ERVs and ventilators, which is super important, right? Checking ductwork, leakage, flows, checking flows, blower doors, right? This is for zero energy ready homes. We're going to test the hot water distribution. How quickly does the hot water get from the source to the furthest fixture, right? We're checking all of this stuff. This is part of your standard certification rating here, right? Okay, so all that's done. We get all your testing. It's all looking good, right? We put it back in the energy model, and then comes out, oh, you're still good. You hit all the marks you said you were going to hit. There you go. There's your CO. You're done. That's how performance compliance works, right? So you can.
The average cost of that thing.
Well, let me show you this next slide, okay? And I'll give you an example. So this is I took a house, an energy model from our program, just as an example. I wanted to see how difficult this code was going to. 2021 IECC has that same wall component of R30 or right. So I wanted to see how can you build a house and comply with 2021? What do you need to do extra, right? So I took that energy model and I played around with it. So we got R38 in the attic, right? Don't need R49. We got R21 in the walls. We have R30 for a framed floor, right? Is anything sounding different to you here? Is this different than any standard home? Okay. Windows are 0.3. Is that a good window? Is 0.3 a good window? That is code minimum, supposed to be. We have an amendment put on that. In Massachusetts, that's the worst window you can legally install is 0.3 in Massachusetts, right? That is not a good window. That's R3, not a good window. Okay, infiltration, all right, so here we go. This is new, 3ACH50, that's new. We got a pretty standard, pretty bad propane furnace. I put in a pretty bad air conditioner, put in a pretty bad propane water heater. Okay, oh, look at this, this is new. Here's an ERV, right? This is a new thing. Energy recovery ventilator, and your standard sort of appliances. Well, that house makes it. That meets 2021 and probably would meet 2024 IECC. We don't know officially because it's still in draft form, but that house would make it. So the only difference in that house is airtightness and an ERV, right? So when you say how much extra does it cost? Well, how much does it cost to air seal your home properly? Shouldn't cost that much. How much does an ERV cost? Panasonic makes the FV10, it's about $900. And then you got to do the ducting, so a little bit more, but you know what you're getting is a much, much, much better house. And in addition, you get something called a HERS certificate, Home Energy Rating System. When you go through our program, we do a HERS score for your project. This is it's a number. It's number 35. So to give you some perspective, a HERS of 0 is a net zero home. So the lower, the better. It's like a gas mileage for the house, right? So another great thing. So this is required in Massachusetts to build a house, right? To get your CO, you got to have a HERS rating done, and you have to hit a 55, which is pretty low. Average in Rhode Island, I think, is like 71. Yeah.
What does the expression ERV, what do those three letters stand?
Energy recovery ventilator.
Ventilator.
Yeah. I'll talk about that in the afternoon session. So this is a HERS score. Look, so you go to buy a house, right? You're going to look at homes and you go to showings, and it's got all the details on the house. And here's this thing sitting there on the counter when you walk in. It's telling you about all the airtightness, all of this stuff. But what else it tells you is this. Look at this. This house is going to cost you $1,300 to operate for a full year. That includes heating and cooling. So that's, what is that, $110 a month for all in on this house. This is a really good house, right? Wouldn't that be nice when you're buying a house to see how much it's going to cost you to operate the house? Yeah. So this is a particularly good house here. R59 in the ceiling, R30 in the walls, super tight airtightness. So this is a HERS rating. If you go through our program, we do this for you as part of the program. All right, now I'm going to just quickly, this is real quick before I hand it over to Steve. I want to talk about Steve for a second. This is one of his houses that went through our program, went and got zero energy ready. Oh no, this is still in construction, but I did the energy modeling for it. And what I did was I took the house and I built it in the energy model as he's building it, and then I built it as it would be if it were just to Rhode Island code right now. I wanted to see the difference of what he's doing compared to code minimum, all right? So code minimum, this house would need 4 tons for peak heating, okay? Under 2,000 square feet, 1,800 square feet, I think, 16, I can't remember. So 4 tons, is that a lot? That's a lot. That's a lot for a small house, right, for heating. So as Steve has designed and is building it, it's going to need 3/4 of a ton for peak heating, right? So that's 3 tons different. That's peak load. That's size of equipment, okay? When we talk about annual heating consumption, this is just for heating, okay? This is not about appliances or other things. This is heating consumption. Built to code, this house will need 68 million BTUs per year. All right? That's a lot for a small house, built to code. As designed, as built, it's going to need 5 million. Right? That is a massive reduction. 90-something% reduction in heating consumption. That's crazy right there. How nice is that? How nice is that right there? So in terms of dollars and cents, here's your monthly savings on this house compared to code. Here's annual savings, and here you are in your 30-year mortgage, you saved $100,000 by building this way. So when you talk about how much does it cost, well, who cares, right? I mean, yeah, we care. We care how much it costs up front, but like, look at these numbers, right? You get it back. It comes back to you. And in addition to this, right, this house is, you're going to have reduced long-term health bills. This house is going to be 8 to 10 times healthier than that code house because he built it tight and he installed an ERV, okay? That means that, and I'll talk about this later, every molecule of air in that house gets replaced and exchanged 8 times a day. Is that happening in your leaky house? Probably not, but really the answer is we have no idea. We have no idea. But we know how much air is moving through this house because we control it. Eliminates future weatherization and retrofitting costs. So Rhode Island has the Act on Climate, right, for 2030 and then for 2050. A lot of the new homes that have been built in the past decade are going to need to be weatherized in the next 10 years to meet these goals. Why are we building houses that need to be weatherized? I don't understand this. I go out and test homes and they fail the blower door. They have to call a weatherization crew to come in and tighten up their brand new house. Where is the common sense in that, right? And also, the rate we're going, fossil fuels seem to be, we're moving away from fossil fuels. This house is all electric, so you don't have to think about replacing infrastructure or changing anything. It's already done. You know, the codes are moving in this direction in terms of energy use, right? And, you know, if you had a linear line, we're sort of here. The end result is down here, right? And Steve's just building to here now. So you don't have to worry about this. You're there. It's done. Right? Okay, that's it for me. I'm going to hand it over to Steve. He's going to talk about airtightness and stuff. But any questions from anybody? Does that all make sense? No questions? All right, well, I'm happy to talk to you about spray foam and the brake, and any other questions you have, come and find me. I'll be around. And in the afternoon, Dave here is going to talk about air source heat pumps, Dave Parker's with Clear Result, and then I'm going to talk about ventilation and ERVs sort of as the build onto this airtightness section here. Okay, thank you. All right.